Fourier series is this function or expression. Here you see John Baptiste Fourier. He made this. He developed this. So the main key is the cosine and sine. Any function, algebraic or any, can be converted to sine and cosine. That is, any voltage or current. These are values. Now this has to be converted into some other domain, say frequency domain. Because if something is in spatial domain or time domain, we are not able to understand it more. But if you turn it to frequency domain, you will be able to find out more out of it. So this expression is actually converting the space or time domain to the frequency domain. So this cos and sine is specifically meant for it. So a Fourier series, you can define it as the expansion of periodic function fx in terms of what? Infinite sum of sine functions and the cosine functions. It is infinite. See, sigma n equals n to infinity. So this Fourier series, you see sine, wherever it is 0, cos is 1. And whenever cos is 1, sine is 0. Likewise. So they are kind of orthogonal. You can say 90-degree turn. So Fourier series makes use of orthogonality relationship of sine and cosine function. So let us take an example, simple example of an image. An image has pixels, brightness values. Now these brightness values are values, just values. So a big image will have multiple of these values. So why not to change it into the frequency domain? Because right now it is in the spatial domain. It is just a grid. It is just a table. Now converting it to frequency domain, now you can have a wide range of application in this Fourier transform domain. That can be image analysis, that can be image filtering, image reconstruction, image compression, all in image processing. Coming to data communication, Fourier series is used in this data communication. As I said, voltage and current, how to change them, how to better analyze this. We can convert from the original domain to this frequency domain, and then we can analyze basically waveform to the bit and bit to wavefront. Fourier series, this is the expression. Now let us take any value p and a function fx. This function is a periodic function. Now let us say we are taking it from negative pi to pi. Negative pi to pi. Let us say this pi is p. We are taking p any arbitrary range. So minus p to p because we are taking piecewise. So negative p to p, which is actually range is 2p, because minus p to 0 and 0 to p is 2p only. So period 2p, you see here p will be, it has to be, L has to be 2p, then only we get a 2p is equals to 2L. So we are taking this p as pi here. If you take negative pi to pi, it can be minus 2 to 2. So p will be 2. So this series is having cos and sine term, and this is a constant a0 by 2. Sometimes you will see c also. So this is c by 2. So for first coefficient an has cos term, bn coefficient has sine term. So a constant, a cos term and a sine term. So this a0, because it is very easy to find out these value an, bn and a0. Just multiply whole of the function with cosine term, whole term with sine term. This is the way some of the part will be cancelled, and you will get a0, an and bn. We are not going into that detail, but it is very easy to find out this a0, an and bn. So now you see the expression. Every expression is integral from negative p to p. For example, you are going to minus pi to pi, or minus 1 to 1, or 2 to 2. So this p is actually this value. And then we have three different coefficient, and these weights will tell you which part is having a more weight, which is lower weight. And that will make a waveform, and that waveform will be a Fourier series waveform. So before we go to the actual example, there are useful identities which we will use. Sin n pi is 0. Sine 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 20 pi, 400 pi, it's 0. So whenever you get sine n pi, just put it as 0. When we have cos n pi, that is any number of cos pi, cos 3 pi, cos 5 pi, any, if it is odd, it is negative 1. Minus 1 to the power 1, because cos n pi is negative 1 to the power n. And if you have odd, you will get minus 1. If you have even, you just get 1. So just write this. Sin n pi 0, cos n pi equals negative 1 to the power n. And depending upon even and odd, you will write the term as negative 1 and 1. One more important aspect of this Fourier series is depending upon even and odd function. If fx is the even function, with even function, if you take this bn coefficient, fx is even function. If we say that we are dealing with even function, sine is odd function, and plus and minus, what do you get? Negative, that is the odd function. So inside you'll get an odd function. From negative p to p odd function will always give you a 0. So bn will become 0. Whenever you are dealing with even function, just forget about bn, you just have to find out a0 and an. Then if fx is odd, if it is odd, see, odd function, negative p to p or negative any value x to x will be 0, because a0 is what? Fx dx. Fx is an odd function, so this will give you 0. a0 will not be there. An, fx is odd and cos part is even, so it will give you negative. That is odd function. Again, the integral from minus p to p or minus x to x will give you 0. So when you have an odd function, a0 and an, just forget it. You just have to compute bn.